Hello friends, this is Dalpat Sonagra, Assistant Professor in Computer Science Engineering Department, Government Women Engineering College, Ajmer. Today we learn the construction of pushdown automata for language L2. This language L2 is a context-free language, and L2 described as a set of all strings that having initial substring W and terminal substring WR, and both are separated by C center marker. This C belongs to a sigma. It means according to this language, the sigma is A, B and C. Means our input string always written with this elements of sigma, where W is any string over A comma B asterisk that is also belongs to sigma. It means W could be any strings with the combination of A's and B's, and W could be any string of purely A's, and W could be purely string of B's. With this, W also contain null, and the WR is a reverse of W. Let's suppose if W is A and B, if W is A and B, then reverse of this W R is B B A. Now suppose we assume a string, input string X belongs to L2, then X is in format of WC WR, like this. Means W is A B B, and in between C is center marker, and this is WR. So this is in format of a string belongs to L2, belongs to L2. So if you understand this, then we go for the construction of pushdown automata that accept all set of strings belongs to L and reject all those strings which does not belongs to L. Yes. Now we discuss logic or idea behind the construction of pushdown automata for L2. Let's suppose X is a string which is belongs to L2. Then that is written like this. Okay, which we can understand in previous slide. So whenever this string W is written over the input A, then idea is we have to push all the elements belongs to W into the stack one by one. Means whenever we read A, B and B, then we push one by one into the stack. And once we encounter C into the tape of input tape of the input tape of the pushdown automata, then we have to change our state. That tell us further we will read WR, and by that WR we have to perform pop operation. The pop operation performs only whenever the element of WR match with the top element of the stack. Means when this W is inserted into a stack like this, Z0 is explicitly inserted into a stack, and A, B and B. Okay, and all these done at state Q0. Let's suppose, and whenever these one by one processed, and we push all these into stack. Once a C is encountered, then we change only this state Q0 to Q1. How we can do this, we discuss later, but just understand the idea. Okay, and after the C is processed, once we change the state from Q0 to Q1, then now this is a WR, which is we read over this new state Q1. Okay, and look, if the matching is performed with the element of WR, and top of the stack, then we perform the pop. By processing this this B, we pop this B from the stack. Again with this B is popped out, and for this A is popped out. So new stack is what? The new stack is only containing Z0, and the whole input string is process. So we are reading what? Null. It means what? Complete input string is processed. So this is the basic idea of construction of pushdown automata for the language L2. Let's discuss one by one these push, pop and no change operation. Okay, here we understand how to push W into the stack. Let's come to the initial instantaneous description of pushdown automata that tell us the machine is in initial state Q0 and input string is X, which is A double B C double B A, and top element of the stack is Z0. Now we have to push this W into the stack. So how we can understand this? So look, we are at state Q0, means machine is in state Q0, and we reading very first element of the input string X over the input tape, and the top element of stack is Z0. So we have to push this A into the stack. Okay, like this. So this A is pushed into the stack. How we can do this? We can do this by writing the transaction function for this. So look at the transaction function delta 1. Whenever the Q is current state of machine and that read A from the input A and top element of the stack is Z0, then that push this A into the stack and change the state. In this case, the state is not changed, that is only a Q0 because there is no need to remember anything, and we push this A into the stack. Now we reach to our next transaction sequence, that is this. This is our current scenario over the pushdown automata. What that is, the machine is in Q0 state and that read B over the input tape and the top element of the stack is A. So because of this B is the element of the W, then we have to push this B into the stack also. So we use delta 5 for this. That is whenever machine is in state Q0 and that read B from the input tape and top element of the stack A, then push this B into the stack like this, and state remain same because there is no need to remember anything, and B is pushed over the top element of the stack. By applying this delta 5, we reach to the scenario this. By doing again, by applying delta 6, we come to this situation to this, that push this B into the stack also by applying delta 6 here. Student, this is my opinion. Please don't remember this transaction function. Try to understand them and construct as and when these are required. How you can understand this, let's discuss. So how we construct these transaction function, uh, we have to push this w into the stack. So w is a string of a's and b's. So delta 1 and delta 2 is the initial situation when the top element of the stack is z0. And if we read a or b from your input string and top element is z0, then we push by using delta 1 and delta 2. Therefore, we write these two transactions. This is the situation initially. After once either A is inserted into the B or B is inserted into the stack or A is inserted into the stack. After these two situations, we have the four combination like this. Either the top element of the stack is A or B. So in both cases, whenever you read A at state Q0, then again push those A over the stack. And this is the situation whenever the top element of the stack is either A or B and you reading B from the input string. Then also push these B into the stack like these, like this delta 5 and delta 6. So all of these transactions are used to push the W into the stack. So finally, using delta 1 to delta 6, we can push W into the stack. And by the initial instantaneous description, after the multiple transaction, we reach to this situation. We reach to this situation, that is the current scenario of pushdown automata after inserting W into the stack. Okay, this. So we come to our next slide. Now we will discuss how to change the state and why we have a need of changing the state and no change operation onto the stack. Okay, so from the previous slide we reach to this situation, that is we are at state Q0 and we reading C over the input tape and top element of the stack is B. So whenever we read C over the input tape, then we have to change the state from Q0 to Q1, and there is no change over the top element of the stack. We can do this by using a transaction function from delta 7 to delta 9. In this situation, we applied delta 9. Okay, after applying delta 9, we reach to the situation where we are at state Q1 and the input string is BBA and top element of the stack is B, which is followed by BAZ0. So at state Q1, notice we are reading the WR, and when we reading a WR at the input tape, then of course we know that when matching is occur with the element of WR and the top element of the stack, then we perform the pop operation. In this case, the current grading symbol is B and top element of the stack is B, so matching is occur. We have to perform pop operation that we see into our next slide. Before this, I want to clear one thing, why we have written delta 7 and delta 8. Because of we have to construct universal pushdown automata. For this, input string X may be delta 7 and delta 8 is not in use, but for any other string, input string, they may be used. So we have to keep in mind that whenever we construct a pushdown automata for any language, then we have to construct universally, because whenever the new input string is come, then that new input string also accepted by that pushdown automata if that is belongs to the language for that pushdown automata is constructed. Therefore, in this case, we have written delta 7 and delta 8 also, and delta 9 is used in our example string. Okay, one more thing is, student, this delta 7 is only used when your W is equals to null. It means the W is null, then WR is also null. Then your input string is only and only C. On that case, that is also accepted because this is also belongs to L2. Only C is also belongs to L2. So on that case, if the machine is in initial state Q0 and you reading C, then change the state Q1 and no change over the top of the stack. Look, also in the delta 8 and delta 9, we just only changing the state from Q0 to Q1, but there is no change over the top element of the stack. Okay, so we clear all these questions. Thank you, and we move for our next slide for the pop operation. Here we understand when we have to perform pop operation and how we can perform pop operation. As per previous slide, we reach to this situation. The situation is the machine is in state Q1 and with reading WR over the input tape, and the element of WR is B, currently under the input head of the control, and top element of the stack is B. Okay, so the matching is occur with this B and top element of the B. So we perform pop operation. This we can done by using either delta 10 or delta 11. But in current situation, we apply delta 11. That is what, whenever the machine is in state Q1, whenever the machine is in state Q1 and the reading element is B over the input tape and the top element of the stack is B, then we remain in the same state Q1 and pop the top element of the stack by overwriting the null. So this B is popped out from the stack and we reach to the next transaction sequence, that is like this. This is the situation. Again, we are at state Q1 and we're reading B and top element of the stack is B. Then of course we have to perform again delta 11. Delta 11. So applying of delta 11 at this situation, we reach to our next situation, that is like this. And after applying the delta 10 over this situation, again we reach to our next situation, that is this. Now the machine is in state Q1 and the whole input string is processed, it is indicated by null, and the top element of the stack is Z0. So this is the situation from which we make the next transaction, that is acceptance transaction. And we know there are two type of acceptance transaction. First is the final state transaction and second is null transaction, that we discuss in our next slide. So after applying pop operation, we reach to the situation like this. We reach in this situation where the machine is in state Q1 and the input is null and the top element of the stack is Z0. So if we consider that the acceptance of this machine is by null store, then we apply transaction function delta. That is what when the machine is in state Q1 and that read null from your input string and top element of the stack is Z0, then eliminate or pop this Z0 from the stack and make the stack empty. This we can done by using delta 12. So when we apply this delta 12 at this situation, then it erases the top element of the stack also. So the next transaction sequence is this. In this situation, the machine is halt. How we can say this? Because there is no access at the stack, because we write null in the stack. Okay, and our input string is processed, and so that we can say that our input string X is accepted. But if we want to make acceptance by final state, then we have to apply transaction function delta 13 in place of delta 12, because only either we provide the acceptance by null store or final store. So at this situation again, if we want to apply the acceptance by final state, then we have to apply delta 12. That is, tell us whenever machine is in state Q1 and input is processed and top element of the stack is Z0, then come to the final state, means state is changed and the top elements remain unchanged and unchanged. So when we apply the delta 13 at this stage, then we come to the situation in this, that is we are at state QF, that is final state, our input string is processed. So this is indication of acceptance of input string X. So this is the construction of pushdown automata. In next slide we discuss all the transaction together and the final all 7 tuples that describe this pushdown automata. By this slide, we can understand the pushdown automata for a context-free language L2. So, one note is there, always we include either final state acceptance or null store acceptance, and that is clearly mentioned into your question. So this table tells us, this is the table of transaction function from delta 1 to delta 11 and the delta function 13. Okay, and for the null storage acceptance, again delta 1 to delta 11 is same for both, but delta 12 is used for the null store acceptance in place of delta 13. So this is the combined table, and by this table we can understand the push operation is same for both of the cases. No change operation is also same push pop operation is also same, but the changes in only acceptance operation. And uh, and the total tuples are like this. In case of final state acceptance, the q is the set of state where the three states are in use: q0 and q1 and qf. But in case of null store acceptance, the only two states are in use: one is q0 and second is q1. Okay, sigma is same for both the machine, that is a, b and c. Of course tau is same. Tau is small a and b and z0. Delta is the given in this table, all the transaction from delta 1 to delta 13 accordingly. Q is initial state, same for both, and Z0 is an initial symbol into the stack. On one more thing, note here, we write subset of final state for the final state acceptance, that is QF, which is belongs to this Q. And in case of null store acceptance, no need to write subset of final state. We mention this null, which indicate the null storage of the stack after the completion of or acceptance of input string. Thank you. Hope you understand. For any query, you can contact at this email address. Thank you very much.